Good morning, everyone, and thank you for joining us today here on Jamesway's Webinar Wednesdays. We are going to be doing the second part of the two-part series that we started last month on the embryo. And this week we're going to be looking at embryo development. As last time, we have Dr. Keith Bramwell here as our guest. He is the Senior Technical Advisor here at Jamesway, and we'll be sharing all his 20+ years of knowledge in embryology. I think we might have a few new users on today. Your user panel is going to be in the top left of your screen. You have your video, audio options there. You can raise your hand. You can answer, putting questions in the Q&A that we'll answer live. You can put those in at any time. And then there's a chat section. You can send us a chat directly if you need to, or you can chat amongst yourselves if there's some questions you have for the rest of the group that is on today. Can everyone give me a raised hand? Just let me know that you all found that. Great, thank you, everyone. All right, so as I said, today is going to be very interesting again. I think we're going to be looking at the actual stages of embryo development, or what's actually happening inside those eggs in your incubators and hatchers, and get a little bit more of an idea of what effects we can have on those. So I will turn it over to Dr. Bramwell.
Thank you.
There you are.
Okay, all right, there we go. Okay, as a follow-up, kind of a follow-up or precursor, however you want to call it, to the embryo diagnosis we did last month. We'll talk about embryo development. And it's kind of a couple different ways I could have gone with this, from the very, very technical to the basics of embryo development and how it could potentially apply to a hatchery and the things we do in the hatcheries. And so I kind of went that direction with it a little bit without getting too terribly technical, at least I tried not to. The egg itself, because the avian reproductive system occurs, or the growth of the offspring occurs outside the mother, the egg itself has to have all the components necessary for embryo development. This is the very basics of our egg: shell, yolk, shell membrane, albumin. This can be breakfast, or in the right conditions, it can be an embryo. So everything that embryo needs has to be contained within that egg at the time it is laid. And that can get kind of technical from the last slide to a little bit more about the parts of the egg. You can see everything here, the different parts of the yolk, other different parts of the egg, and we will talk about some of these things and how they contribute to embryo development. All of these things here have to be in place at the time the egg is laid. The only difference in this, in that statement, is the air space or air cell itself. That actually is created after the egg is laid, and some people don't understand this and how that occurs. But when an egg is formed in the hen, that shell is completely full of all the contents that we see here. As that egg is laid and is exposed to air, there begins to be some moisture loss, and that moisture loss then will cause this air cell to form. So as the egg moves through development, the embryo development, the egg itself, that air cell will continue to increase in size, and it does so as we have moisture loss. Interestingly enough, you can take an egg out of the oviduct, and directly out of the oviduct, and there will be no air cell, and within minutes, you'll hear a little pop, and that's the membrane separating that's causing that airspace. Other than that, everything in that egg here is formed within the hen. Because the purpose of an egg is for reproduction, specifically for reproduction, if these factors are not met, in other words, they don't have enough protein in their system to develop a proper albumin or fat to develop proper yolk, they're not going to lay eggs. I mean, that's one of the first things animals do for survival, is they will stop reproducing to preserve themselves. So typically when an egg is laid, it has everything it needs to develop an embryo, and if not, then the hen typically will not grow or lay an egg. So when we talk about embryology, we can say, okay, it's kind of like building a house. In a previous career of mine, long ago, I was one of the Steps in construction. I hung sheetrock. In order to hang the sheetrock, we had to wait till all the other components of the house took place. You know, they had to dig the trenches, they had to put a footing, and then the foundation, and then the slab, and, you know, build the walls and the roof and the electrical wiring and plumbing in the walls before we could do our part. You can't, most of those parts you cannot do out of order. When it comes time for me to do my part, everything else needed to be done. We went ahead and put the sheetrock or the gypsum up on a wall before the electrical work was done. It can't be added later, and we have a problem. Same with an embryo, is we have parts that have to occur in a specific sequence and in the order designated to develop a complete embryo. And so we have to remember that all along as we move through this. Okay.
Sorry, everyone.
Little confusion there, but that's all right. But we need to remember that as far as embryo development, everything has a time and a specific place that needs to occur. Okay. How's it not working now?
Sorry.
Okay. So when we look at the stages of embryo development, we can kind of break it up into a couple of different parts. Some people don't like this slide here with all the little pictures on it, but I used it anyway. But we can look from day 0 to the final stages of embryo development. We will go through these a little bit more detail as we move forward. We can kind of break it, or I break it up into 2 distinct parts. This first, up to 12 days, is what we call differentiation. Differentiation is going to begin earlier than 12 days, obviously at 2 to 3 days, but there's parts that are still developing up to 12 days. What differentiation is where you're taking a mass of cells, and we'll talk about the cellular development. We'll take a mass of cells, and at different stages, it's like you're going to go be brain cells, and you're going to be kidney cells, and you're going to be nerve cells. And so the cells are being differentiated into the parts and components of the embryo, and that is necessary for growth of that embryo. Some of those things are done and completed in the first 2 to 3 to 4 days, and there's a few things that are still going out to 12 days as far as differentiation. And then after that point, we really just have growth. We have growth of that embryo. Everything is basically in place as far as the embryo is concerned. And then we just have the growth to the end, latter phases. We can kind of look at the growth phase. I have it here as 13 days to whenever, and in reality, parts of that growth phase are really starting at 5, 6, 7 days. But it kind of encompasses the middle portion to the latter portion, with the first part really the differentiation and some growth. So these are kind of the different phases of our embryo development. Bottom line is we're just trying to produce a chick. And you think about it, this chick is formed, developed into a healthy living chick from the contents of an egg, and that's it, with no outer influences or additives of nutrients. It's all in that egg at the very beginning. Okay, so where does our embryology start? Obviously, it starts at fertilization. And there's a myriad of things that occur as part of the fertilization process. And I won't go through all of these, but in case you weren't here last time, I'll talk a little bit about fertilization. Insemination, whether it's artificial insemination, which is done commercially in some parts of the world, or natural mating, insemination has to occur properly. Semen has to be deposited into the hen. And then there's a sperm storage in the hen, sperm transport to the site of fertilization, then our actual final fertilization occurs. Fertilization will occur in the upper portions of the oviduct and the infundibulum, and that occurs within the first 5 minutes after ovulation. And it must occur in those first few minutes of time, because as soon as that egg is being formed, we saw in that earlier cartoon diagram that we had a egg with some albumin right around that yolk. As soon as that albumin is put around that yolk, there's an enzyme inhibitor there that prevents the activities necessary for fertilization. Then we have shell formation, 24 to 26 hours to complete, and this occurs within the hen, and the hen's body temperature is 40 to 41 degrees Celsius, or 104 to 106 Fahrenheit. So that temperature is obviously a warm enough temperature for embryo growth. So when that egg is laid, then we will have 1 day's development of about 20 to 40,000 cells as part of that embryo growing. I talked briefly about the sperm cell storage, and I won't talk a lot about that now, but that is a somewhat unique thing to the avian system. There are a few other species of animals that practice sperm cell storage, but for our avian species, it is a necessary component to fertilization because we have an oviduct that is full most of the time with an egg that's being in various stages of formation. So the hens have to store sperm and make it available for fertilization at the exact time. Next stage in fertilization, once that sperm is stored, gets to the site of fertilization, they recognize binding sites, they undergo an acrosome reaction, they digest and penetrate a hole into the membrane to gain access to the female genetic material, and that is at the dermal disc area where fertilization will occur. We can look, and hopefully it shows up on your screens at these two eggs, and we can see the differences between an infertile and a fertile egg before incubation. The egg on the left, the blue arrow pointing to it, is an infertile egg, and the one on the right would represent the germal disc area of a fertile egg. And you can see in that fertile egg, we see a donut-shaped fashion or germal disc area, and the infertile egg on the left, we see more of a compact area or region. That fertile egg, that donut-shaped area is essentially the cellular development that we talked about.
Pause there for a second. We have a question from Jacob on this, so I thought it would be a good time. He's coming off of the last presentation. He's asking, how do you train your staff to identify a blood spot or an infertile egg versus the fertile in notating those accurate fertile-infertile records? That
really, I mean, it's a hands-on type of activity to train to know the difference between fertile and infertile. But the main thing you mentioned a blood spot or a meat spot. One thing we need to understand is that we can have other tissues that are in or on that yolk that you may think, oh, there's a spot of blood, this is embryo development. See how this fertile egg is growing in a circular fashion. Well, if you see just a spot, just a chunk of tissue that's just sitting there that doesn't look like like something's growing around it, it's more likely just a piece of the follicular wall that broke off and that got encapsulated as that albumin was being formed around the yolk. And it's same with a blood spot. You can have a blood spot that if you see that material, foreign material, it doesn't necessarily mean that you had an embryo growing, it means something was there. Think of how the embryo grows. We look at this fertile egg and we have a little donut, and the next few slides I'll show you, when I get to them, you can see that donut area is growing and encompassing that yolk, so there has to be a pattern to that growth and to the point that it completely encompasses the yolk. If you see just some other material in there, but it doesn't look like it has any growth or pattern, you're probably just talking about a piece of flesh or a blood spot.
So you're looking for something fairly circular and not sort of
Correct.
irregular edges.
Correct. Now, you get out to 21 days after eggs have been in the incubator for that period of time, and say one died in 1 day development and set in an incubator for 20 days. Yes, they won't all look like this. There will be some differences the way it looks. You might have some other breakdown of the yolk material, but you really need to find that dermal disc, and you find it, and if you can see those two differences in there, the embryo development will occur in some sort of organized fashion.
Yeah. So I think it really will just come down to practice,
Right.
to getting everyone together and maybe doing some breakouts together and saying, okay, this one we are classifying as fertile, this one we are classifying as infertile, and why, and doing that, semi-regularly with your people so that everyone stays on that same page.
Exactly, and that's a key factor, is getting everybody together. When I do a training, what I often like to do is let the individuals there, like, say, okay, who normally does your breakout? Okay, you do it, and I'm going to watch, and I'll let them go through. And most of the time, they're accurate. And when there's a question, sometimes I throw a question out when they were actually right, just to see how confident they are. But if there's a question, I ask this: is okay, so why did you call it that way? And then you can do a little bit of training and understanding and discussion on some of the ones that are a little bit close. But that's the key, is to get everybody together, make sure everybody's on the same page. What you don't want to have happen is have a different person do a breakout one day, and all of a sudden the results are significantly different than any other day, and then you think, oh my gosh, something's horribly gone wrong in our hatchery, and in reality, you just had a different person that interpreted things a little bit differently.
Yeah, for sure.
Okay, ready to roll?
Yeah.
Okay, good question. Okay, looking at the relationship between fertility and embryonic mortality, I've talked about this numerous times over the past years, but real briefly, I'll kind of tie this relationship together as because a hen can store sperm, we can have a insemination occurring at a specific point in time, and then if the hen is not mated, she will continue to lay eggs for 2-3 weeks. People always ask me, how long can a hen store sperm? Well, some 10 days and some 28 days. You know, there's a big variation there. Again, we're talking about biology, so there's variation there. However, what happens in this chart you're looking at here, on the bottom it says days post-insemination, and that would be the days after the hen was inseminated, and we're looking at fertility in 4 different amounts of sperm we inseminated hens with. But if we look at this group where we're looking at overall fertility of the hens on what is a normal insemination dose of 100 to 200 million sperm, we can see out at 8 days fertility begins to significantly drop, 8 days after a single mating. 10 days, 12 days, 14 days, we see that fertility continually drop. The red line is the percentage of those fertile eggs that died in early embryo development. Regardless of what you do, again, we're talking about biology, so in perfect conditions, you can have 2 weeks after a single mating, your fertility may drop to 40% or less. Of those 40%, nearly 20% of those are going to die early embryo death, and then that continues to increase. The reason why I bring this up is there's a specific tie. In last month, we talked about this, and I had a follow-up phone call the next week. We talked about it in length. There's a specific tie into that when you start seeing fertility drop, particularly in older flocks. We often see this embryo mortality increase, and it was like, yeah, it happens. Well, this is one of the reasons it happens. And that can give you indications of why you're having fertility problems in your flock, and when we see the embryo mortality increase. So we can have sperm that maintain the ability to fertilize, but they may not be as viable of an embryo. So we have to remember that the embryo mortality will occur when our embryos are stressed, and sometimes they're a little bit more susceptible than other times, depending on conditions. So going more into the development, fertilized egg, again, we looked at this a little bit earlier. We can see the embryonic disc or germinal disc and the area pellucida or opaca where the embryo is beginning to grow. Day 1, a little bit closer, we can look at that donut shape we're talking about, and the picture on the right is a little bit more pronounced, so we're having a little bit more development. That's what we're looking for. We're trying to determine if we had a fertile egg. Some people I've talked to would look at this egg in a breakout and say, well, there's no blood there, so I don't think it's fertile. We have what we call fertilized eggs that die before they ever get to hatchery and never start again. That's a difference in hatcheries and breeder farms sometimes calling fertility is, sometimes hatchery might say, well, they're just infertile, there's nothing we can do about it. Well, in reality, even if they die before they ever restart in the incubator, it's still not a hatchery's problem. It's still a fertile egg that died due to a factor prior to the hatchery. But we really need to see this before we call something infertile, some sort of growth. Again, a fertile egg, 12 hours of development, we can see that donut starting to grow. 24 hours, again, that's the start of that embryo. See how it's beginning to grow, and it will eventually encompass that yolk. So this is 24 hours of incubation, after the egg is laid and put in the incubator. And this is just for your information as far as staging, embryo staging. There's a really good article that came out in 1951, Hamburger and Hamilton, and everybody talks about stages of development using the Hamburger and Hamilton model. There's been a little bit newer come out, but this is kind of the standard. So when I talk about a little bit of our stages, a lot of times I refer back to that model. So real quickly, a couple of different things as far as cell division. The cleavage division, there's a decrease in cell size without a change in total mass. So in other words, our yolk is obviously stays the same size, But because we see that donut-shaped area and there's 20 to 40,000 cells, they're still contained in relatively the same area. So we have the cells themselves are decreasing in size, but they're multiplying in number. That's how we increase the amount of genetic material, DNA, at that dermal disc area without the cell itself or the area actually growing. We're still just creating a mass of cells. Two different types of cleavage. The avian system is a meriblastic cleavage, incomplete and equal cleavage. That's what we're talking about as far as their cell division, but it's not increasing in size of the whole mass. There's just a increase in cell numbers. These are eggs like our avian eggs, large amount of yolk, one end of the ovum. So this is what we see as far as the cleavage. You can see on the bottom right, multiple cells in that area compared to the upper left, where we basically have 2 cells, then 4, and then 8, but the area itself is staying relatively the same size. We're just going to increase in cell numbers and increase in DNA material without necessarily an increase in mass. The blastulation, next phase, it's a area that will form segments of cavity. It allows the cells to basically have a place. It's a kind of, it creates a space where the cells can move into during the formation. During gastrulation, you have the 3 primary germ layers: ectoderm, mesoderm, and endoderm. So really early, we're getting our 3 germ layers that are necessary for the embryo. This is real early. This is you know, you're not seeing any of these things occurring in the embryo, but it's a very critical part of embryo development. And again, this has to occur in this very early stages of development. Cell movements starting to occur. That oval position, the embryo is in the late stages of this gastrulation. So at the time the egg is laid, we already have our 3 germ layers formed in that embryo. So we already have some basis and some foundation of the embryo itself, and what's going to happen as far as development of that embryo. So we can see a couple pictures here, which I won't spend a lot of time on, but if you get this after the fact, you can spend a little bit more time looking at these. So looking at our extra-embryonic membranes that we're a little bit more familiar with, the yolk sac, it accompanies a vitellin circulatory system and envelops the yolk. We saw that development start to occur around the yolk, and the yolk sac will secrete enzymes, or an enzyme that acts to change the contents of the yolk into a form that it can be utilized by the embryo as nutrients for the embryo. So again, that is a very important function to allow the embryo to get all the nutrients it needs, because remember, everything it needs to grow has to be contained in that egg, and it has to be in a form that it can be used. The amnion, next membrane is formed. The fluid sac surrounds the embryo. Main function of this, it's a kind of a transparent fluid. Main function is to allow the embryo to be protected from shock. It kind of floats in there. It keeps the parts from sticking to each other and adhering to each other. So it's kind of like a cushion, I would say a liquid cushion that the embryo is able to sit in. The allantois and the accompanying circulatory system, this is one of those that will begin forming at about 3 days of age, but is not entirely complete till day 12. So that is one of these that takes a long time. It starts early, but there's various stages of development clear through day 12. 3 main functions of the allantois: respiration, oxygenate the blood, removes the carbon dioxide, the CO2. Excretory removes the excretions from the kidney and deposits them into the allantoic cavity. You have to think of that as anytime you have a metabolic function of embryo growth, embryo development, like we have here, there's always waste. Well, what happens to that waste? That waste is then collected here in the allantois and is there at the time the chick hatches. It's got to go somewhere, and it's not able to release some of the waste it cannot release outside of the egg. It stays there until the time it hatches. And then there's a digestive function, aids in the digestion of the albumin and absorption of calcium from the cell. A lot of the calcium, we see this chick that was at one point a couple of cells, and now it's got a skeleton, peak and down everything. That shell is a major contributor to the calcium needed for bone formation. And so it will continually draw that calcium from the shell and utilize it for growth and development of that embryo. So that's another function if we have poor shell quality. One, we may get excessive moisture loss, broken eggs, cracked eggs, but also we need to remember that that shell is a contributing factor to the calcium or the skeletal development of that chick. And then we have the serosa, the chorion. It functions as part of respiration, oxygenates the blood, and CO2, removes the CO2 from the blood, and assists the allantois in completing its metabolic functions. So these are some of the extra-embryonic membranes that are formed and developed very early. Again, these things are happening early. They have to happen properly. So at the time these are developing are going to be the times from right about the time the egg is laid and the next few days. Many of these things are still developing and forming. And so if we have issues that prohibit this from developing properly, they're going to result in a chick that does not have the ability to survive. One of the things I always like to look at when we talk about mortality is, you know, what causes mortality of anything, of a chick or whatever, is a period of stress that the living being, embryo, whatever it may be, cannot overcome. So if we have a stressor that affects development of some of these necessary components of the embryo early on to the point that embryo dies, we have to consider the fact that majority of the other embryos there also have that same stress, but maybe not to the point that they actually cause death of them, but to the point that that could then hinder their effectiveness and productivity as they continue to develop, because they indeed were stressed in the same manner, just not to the point of mortality. So we have to look at that. Anytime we have early mortality, late mortality, we're nearly always going to see a combination of an effect on chick performance in the first few days of placing, and even all the way out to roller performance, which we've seen in some of the studies that I've been involved with. Okay, looking at the various stages of development, and I'm not going to talk about all of these points on every slide. There's a few things I will bring up. Of course, day 0 of incubation before the egg is laid, fertile or infertile, determination will be made at lay, and the fertilization process would have had to occur 24 to 26 hours before that egg is laid, right after the egg is ovulated. So at day 1, there should be visible tissue development in an organized manner. We talked about that with that question a little while ago. What constitutes really an early dead and a blood spot or meat spot? We have to have some sort of organized manner. We're not just going to have randomness of cellular development. I say we're not. It does occur. It just doesn't occur in a live, viable embryo. We do have that occasionally, and those are certainly embryo mortalities. But we will have visible tissue development in that first day in an organized manner. The extra-embryonic blood island formation starts, or neural folds appear. Various other things you can read here if you get this after the fact, but there's a lot of different things just starting. We don't see a lot of this. Day 1, really all we're seeing is that there's some visible development. Day 2, the picture here, day 2 is probably a little bit beyond this day 2 point. We typically aren't going to see this much blood and this much development, but it's probably a late day 2. We see further tissue development. What you'll see up on the top in blue is what is visible. The other things are what is occurring to the embryo that are not necessarily visible to the naked eye. See here I have differentiation, day 2. Brain, eye, ear, pituitary, kidneys, forehead, all that stuff, all the cells are designated to where they're going to be and what they're going to be part of. When I talked about last time, and I think it's important to bring up again, we have several peaks, or a couple different peaks in normal embryo mortality. One is about 2 to 3 days of development, of embryo development. One is going to be about 19 days, and one is going to be at 21 days. The normal embryo mortality at 2 to 3 days, normally we can see 2 to 2.5%. That's normal. That's biological, because differentiation is occurring here. So when we compare this to a mammalian system where we see miscarriages, we see aborted fetuses, and we've got cows or dogs, or even in humans we have failures of reproduction. often those occur during this phase of differentiation. If all the cells aren't going to the right place and this is trying to develop with not enough material to be a brain or an eye or ear, the developing embryo is going to die, whether it be a chicken or whatever. So this portion of differentiation is very critical. Notice that occurring at this point in time. So we can think of, okay, so if we have excessive stresses at this point in time, when I've tried to overheat embryos to the point, I mean, excessively overheat them early on, I didn't necessarily kill the embryos at day 2, but I had a lot of, when it was too hot, I had a lot of death about day 8. What was happening is I'm sure some of this differentiation was being altered to the point that the embryos couldn't quite develop normally. So we can think of different stressors that could occur at different stages that will eventually cause mortality. So day 3, embryos start to turn on its left side. Again, these are the things you can see. Pigmentation of the eye is beginning, the heart's beginning to beat. You know, some of the other things, eye development is causing the embryo to become responsive to light. You know, some of these things you're not necessarily going to see unless you're really trying to. Day 4, the eye is well pigmented and visible. You start seeing leg buds, wing buds. The reason why this eye well pigmented is in red here is that's one of my key factors when I'm doing an embryo diagnosis, like I talked about last time, is that when they hit day 4, if you look at an embryo and you can see an eye, pigmented eye, you know it hit day 4, and you can categorize that as a 1, 2, or 3 day development. So that is a function that's occurring at day 4. Other things are occurring also. You can see more differentiation of the crop and kidneys becoming functional and brain connections are forming. So we have a lot of things, wiring, so to speak, that are occurring at these stages that are instrumental as we move on and basically building our embryo. Day 5, start using the elbow, knee, toe buds are visible. Again, some more parts of necessary parts of the embryo developing: testosterone, corticosteroid, synthesis beginning, spinal cords, activities being detected, spleen differentiation, heart, allantois. So these are important parts of the embryo that are occurring that need to occur properly to get us an embryo that'll work for us. Day 6, start seeing toes, upper and lower beak, parent, uneven in length. And again, you can see the other list of activities occurring. Neuron cell formation, amnion begins to contract rhythmically. Active transport of amino acids. So these parts, again, are part of the building blocks, you know, building the house, so to speak, or building the embryo, occurring at these various stages. Again, you cannot back up and do this after the fact. It must occur at this time. You can incorporate this to the times of incubation and what we do, how critical it is to stay on track with providing them the environment they need to make sure all along the way we're getting the development we want. Day 7, we start to see feather tracks more visible. Again, we see things like the liquidogenesis in the liver begins, air sac differentiation, sexual differentiation begins. You know, we're finding out if this is going to be a hen or a rooster. This is occurring very early at a time where those cells are being moved to the areas that there will be needed in the embryo and they'll be part of that embryo. Day 8, in the red, egg tooth present distinct. Again, that's my distinction that an embryo has moved into that middle phase of development, that 8 to 15 week time period. The egg tooth can be very present. We also have other things. You know, the parathormone synthesis begins, ACTH secretion begins. Really, when I talked about at day 7, the sexual sex is determined. At this point, they're really determined as far as in the hens, the Mullerian ducts will develop and they'll recede in the male. So we're very early on, we've got a differentiation of cells as far as sexual determination of those embryos. So we can see the egg tooth very prominent on this embryo here. Day 9, eyes closing, extending toward the wings. We have thyroid synthesis, chorioallantois fix the shell, stomach contents increase. So again, just some building blocks. Day 10, start to see toenails, comb, wattles. Embryo's positions begin to be fixed at right angles to the axis of the egg, and that's not necessarily hatching position, but it's starting to be fixed within that egg. Day 11, various cell death programs are underway. What are cell death programs? They're parts of the development of the embryo, cells that are necessary for development, but those cells are not necessarily necessary for survival of the embryo at a later point. One of the things that we can really see as far as cell death that stands out, if people have noticed on newly hatched chicks, on the back of their head, there's a muscle on the back of their head. This is not necessarily occurring at this point, but when they hatch, they have what's called a pipping muscle. That muscle has one function: to help them pip out of the egg. When they hatch, cell death occurs to those muscles and it's gone. They don't need it anymore. It's called apoptosis. It's programmed cell death. And that's a visible thing you can see on a newly hatched chick that you don't see within a few days, because we have that cell death. So we have that as well in the development of the embryo. When we have functions that are no longer necessary, we have certain death of cell programs because those are not necessary anymore. Again, it's all conservation. We're developing an embryo inside of an egg. Day 12, absorption of the albumin begins, calcium absorption, other things are occurring here. Day 12 that basically is when we have completion of the differentiation stage of the embryo, which means that at this point, everything is in that embryo and should be in place for what that embryo needs to develop. So from this point on is when we really begin that growth stage, because we are not building new parts of that embryo, we're growing the parts that have previously been placed in that embryo. 90% of the organs are developed and are fully developed and present. And then you have your embryo size will begin to really grow during the growth phase. Day 13, start to see scales on the body, on the legs. 14, embryo's turning, starting the hatching positions start to be fixed, turning, they become sensitive to sound, which is some interesting thoughts as far as embryology and development. They start communicating with each other, and when we look at nature and how that happens in nature, there's some benefits there and reasons why they're able to communicate. Some imprinting actually goes on in some of our wild bird species, where they put sounds of the parents in the incubator in the last week of development, so when they hatch, they recognize those just from what they heard while they were in incubation. Day 15, we have thyroid activity, stomach begins to contract again, additional growth. 16, hatching positions well fixed. They're capable of respiratory movements as far as they're starting to develop that respiratory system to a point that it will function. Day 17, the amniotic fluid decreases. Again, your hatching positions get more fixed, the head's moving down between the legs. Day 18, the yolk stack is still on the outside of the embryo, but it's starting to be withdrawn to the body. And that's one of the things when I'm looking at embryo breakout in late stages, is you start thinking, okay, when is that yolk going to start to be withdrawn? Well, of course, it's starting to be withdrawn. Day 18, we start to see the beginnings of that yolk really being pulled into that chick. At day 19, it should be there. It should be all pulled within that chick. And so when we do a breakout like this one here, this is in that 19th day, we see a little bit of yolk material hanging out of there. So what happens if we have a finish line on these? At 21 days is our finish line. These chicks have to be done. So what happens if we delay it all along the way and we're getting right towards the end and we didn't have enough moisture loss, we didn't have the growth we should have because of conditions were too cool or whatever, and we get to that point that it's supposed to be pulling that yolk sac in and getting ready to hatch? Well, it's going to try to hit that finish line, but if we delayed things along the way, that's why we might have some open navels and different things like that, is that the chicks never quite hit all their targets along the way. Day 19, we have pulmonary respiration. It's initiated. That is when that chick pips into the air cell. As soon as he does that, that's when that pulmonary respiration is initiated, begins. That is our second peak in embryo mortality, is when pulmonary respiration is supposed to be initiated at 19 days. They pip into that air cell, and all of a sudden they're supposed to take that first breath, kind of like the baby, they try and take that breath to get going. If it tries to take that breath and it doesn't work, something malfunctioned along the way, we're going to have some embryo loss. And we see that there's a peak in embryo loss when pulmonary respiration is initiated, 19 days. 20 days, that yolk sac should be completely withdrawn into the cavity. The clicking, the internal talking of the chicks to each other begins. Not as much of a function in the commercial poultry industry because of the nature of our incubation systems, but in nature we see that more. And at day 21, of course, we see hatching. So in kind of finishing up here, again, going back to these points we talked about of embryo development, we talked about cell differentiation. That moves through, like the choriodental membrane will move through about 12 days before that is completely formed, and differentiation then is completely completed at day 12. However, at day 2 and 3 is when we really see a peak in the beginning of that cell differentiation. Because it's a biological system, you never say never, you never say always, because something's always going to go wrong, or everything can't always go right, but everything can't always go wrong. But this is when we're going to see some deaths due to just biology. We have a biological system. We're trying to mimic nature, but we can't necessarily do it, mimic it exactly all the time. Day 19, we have the switch to pulmonary respiration. That's when we see a peak in mortality. And then the hatch problems, we see in the chicks difficulty in getting out of the eggs. So this is kind of summary of the embryo development, kind of tying it into a little bit of embryo diagnosis, but wanted to stress the importance of really, we're like building a house, we're building a chick. We have very specific needs that have to be addressed. It's why when we come back and start looking at an incubation profile, start looking at the final product, the chick in the hatch room or out in the field, we look at that chick and we're trying to determine, okay, was it built correctly? If we have some issues with it, that's why we can go all the way back to the incubation profile, or if you're in a multi-stage machine, to the machines themselves. Are they ventilating right? Are we getting the right environment? Because we have to build this in a proper manner, and if we don't, we may not cause mortality early on, but we might cause a situation later when the chicks are older, and we see that in the form of mortality, either as chicks or as embryos or as chicks.
All right. Thank you so much.
Any questions?
Any questions? That was incredible.
Seemed like I always fly through that, but willing to answer questions.
No, it was good. So if anyone has questions, you can throw them in the Q&A, or you can also put them in the chat if you're having a hard time finding that Q&A panel.
And I'm always more than willing after the fact to talk with you, answer questions. I know from the last one we did, I've had numerous conversations with individuals that either saw the webinar later, didn't see all of it at that time, or saw parts of that time and can ask questions, and I was able to have some one-on-one conversations with them. And I'm always willing to do that as well. So if you have some questions that don't really want to ask them now, then
for sure,
shoot them up here and they'll get to me. Or
yeah, you can always email us. You can find Dr. Bramwell through Facebook as well, and LinkedIn, and all those sort of social media out there. You can just email the webinars at jamesway.com. You can just email any general Jamesway website, email your sales rep. He'll send things through to us. No matter how you contact us, we'll make sure that the information gets to you. And that is a good point, that everything is up on YouTube. All our past webinars are there. So you can always refer back to those if you need them. We'll also be putting all the PowerPoint in a PDF form up on the website, the jamesway.com/webinar-Wednesdays page, where you can not only register for upcoming webinars, but we'll also have in the bottom, there are the links to the YouTube videos, and we'll add the PDFs of the files down there. We do have some questions from Jacob. He's asking about allantosis. Can the incubator room be fumigated while embryos are exchanging oxygen to carbon dioxide at this stage? He gave us a house analogy. Is the house running on the central air at this point? When does air transfer go from the interior to exterior oxygen? Is that at day 19 or?
Trying to put those questions together.
Yeah.
Typically, addressing the first one, we're asking about fumigation at the times when the embryo development. We typically don't do that. Those that fumigate and have had success doing that typically are fumigating eggs before the incubation process begins. Now, again, never say never, never say always. I have heard some people that did some interesting forms of fumigation during the incubation process. It is not recommended. I don't really know how theirs work, but it seemed to help. As a general rule, we don't encourage any sort of fumigation during the incubation process. Second part of the question, I'm not exactly sure what he's asking about.
I think
I think it was when the,
when is the oxygen that the chick is receiving while in that egg? When is the oxygen that we're actually putting into the incubator through the fresh air supply?
okay, well, let me talk a little bit about that, about oxygen and CO2, because that's a little bit, that's a different philosophy than has been believed for a long time. As a matter of fact, I was reading some literature in the last week or so, some older literature, and they were just, it's very different than what we talk about now. It's like a lot of beliefs are, we've got to ventilate, we've got to ventilate, we've got to ventilate these eggs. They need oxygen, they need oxygen. And for our single stage equipment, what we have found with our single stage, when we have all our embryos of the same age, we actually will not ventilate up to 9 or 10 days of age and allow CO2 to develop. We actually want it to develop. Now, in smaller incubators and older incubators that are not quite as tight, it's really hard to get a good elevation of CO2. But some old literature says that you will get embryo death if you get 1,500, 2,000 parts per million CO2. Well, that's not the case. Up to 10 days, we will allow CO2 to develop to 9 to 10,000 max parts per million, and it's not only okay, it's beneficial for that developing embryo and beneficial for the chick's performance after hatch. So to kind of answer your question, up till 10 days, we really don't want to put in oxygen. We want to allow CO2. I've actually put incubator or thermometers under chicks or under chickens that we're setting and watch them. First 10 days, they will sit on those eggs really tight. They rarely get off the eggs. And I think that's one of their mechanisms for allowing CO2 to develop and providing the heat and warmth that those eggs are requiring at that time. After about 10, 12 days, the hen starts getting off more and more where they need a little bit more fresh air. They're producing more heat, so we need to get rid of some of that heat. We need to let some of that CO2 escape and add fresh air in there. So about that 10-day time period is when we really start saying, okay, now we need to add some oxygen in there. We don't really add it, we just open the vents and allow it to naturally pull it through. So I'm not sure if that answered the question, but it got me on something to talk about anyways.
I think part of the reality is that egg is always in exchange with the environment around it, right? We're having moisture loss to the environment, so you're going to have something has to go back in, right? And that's going to be air, whether it is high in carbon dioxide or regular air with regular oxygen content or a fumigated air. So you have to remember that egg is not really a sealed compartment, that it's constantly undergoing that air exchange. So no matter what you fumigate in that space, that is going to be leached into that egg during that process. So you do have to be careful there. I do think I have knowledge of one client who does vaccine eggs, who has a fumigation process during the cycle. It was a very long time ago that I worked with him on that, so I don't remember the details.
And they're not hatching the chicks either.
And they're not hatching the chicks either, right? These are vaccine eggs, so it's going to be a little bit different. But I have heard a little bit about that, but definitely not as a common practice at all.
And back on that CO2 thing, just to clarify, because having said that, then I think back of questions I've had after that. That is a big proponent, and that's one of the things that with our machines have an advantage in allowing that CO2 to build early on. That is for single stage incubation, because I can't even tell you how many times I've been asked this question after I made the statement I did. Well, can I do that in my multi-stage? Yeah. No, that is single stage. If you have eggs in an incubator of various ages, you do not want CO2 to climb on embryos that are 12, 14, 16 days of age, because we will get embryo mortality if we allow high CO2 levels. So we can't do that if you have equipment that's got multiple ages of embryos.
Yeah, exactly. So you do need to make sure that you're, finding that equilibrium state for everyone in those. So. We have a question from Andreas. He's asking, how often do you recommend turning during the first phases of incubation?
Well, most of our equipment is set up to turn hourly, and we found that's, that gives us the best results. I was looking at some research not too long ago where they were turning even more frequently, and at various stages it sort of seemed to help, it seemed to not. From a commercial aspect, with our machines set to turn on an hourly basis, that seems to be the best mode of operation. Now, if you're talking about a really small, what's the minimum? And the minimum, I've seen people turn 3 or 4 times a day, and they can get the necessary benefits of turning, but that's when you're a really small operation where you don't have automatic turning, or you have old turning mechanisms that you can't really program to be an hourly turning. But most of our equipment now that are programmed in for a specific time to turn are turning hourly, and that's specifically what we want to do. Our turning needs to be done the first 2/3 of incubation. So when we get back on chickens after 14 days, and some of our Jamesway equipment, I know, are multi-stage, will actually turn the turners off on the last position in there to help with airflow in there, and the embryos really don't need to be turned after that last week. And I say first 2/3 of incubation, because then we start talking about turkeys or 20-day incubation period, or some ducks that are longer than that. So we say first 2/3, but it's very critical, that first 2/3 of incubation, first 2 weeks in chickens.
Yeah. Jacob has another question. Thank you, Jacob. He's asking, in your experience, have you noticed a change in development based on a washed egg? And he's washing in a ClO2. I'm not sure of the technical name of
I'll just
that.
address washed.
And then, yeah.
Not necessarily changes in development when you wash eggs, but you have to be particularly careful if you're going to wash eggs in general. There is equipment out there that can control the conditions to wash eggs properly so it works. The problem is that if you're trying to wash eggs and you're using any solution, and you have eggs that were laid that day, and you've got a solution that is warmer than those eggs, you're trying to wash the surface of the eggs and get them cleaned off and using clean rags each time, we can see some benefits into the bacterial load challenge of the chicks, particularly when they're washed in a proper manner. Doesn't really change the embryo other than potentially the potential challenge of bacteria. However, if you're washing eggs and you're just doing it with equipment that is not designed to do that, the potential problems are far greater than not doing it at all. For instance, if you have a warm egg and your wash solution is cooler than that egg, the pathogens, the bacterial load that's on the outside of that shell that you're trying to get off, you just put a cool water on a warm egg, and then that egg will then pull in that cool liquid that was on the outside, including some of the pathogens that were on the outside. You've now sucked them into the egg. So you've made a bigger problem.
Yeah.
So as a general rule, we just don't like people to wash eggs because it's hard to just always keep that wash solution warmer than the egg. But that's the most critical thing, is to keep it warmer than the egg. And if you're doing that and not allowing anything to get in, you're just cleaning off the surface of the shell, and you're going to produce a better quality chick.
Yeah. I actually attended a really good presentation on that at the Ontario Hatcheries Day in the fall here, Jacob, and I'll have to look back and see if I can figure out who the presenter was. But if I can do that, I'll shoot you a little note just letting you know who that presenter was, and maybe you can get their presentation from them and look at that, because they had some nice slides that they had done, in terms of actually plating what was on the surface of the egg before, after washing the inside of the egg. That really showed that, even though you're washing the surface, the inside of that egg is still going to be more contaminated from a dirty egg than it is, or from a floor egg, than it is that good clean nest egg. And so the message there was the same, to not to preferably not use them if you don't have to.
Now, I know people that raise like waterfowl or pheasant, that the birds, almost no matter what you do, they're going to lay their eggs on the ground, and they're going to be a muddy mess. They almost have to clean the eggs, but they have to make sure all the precautions are in place to make sure they're not causing a bigger problem by allowing an avenue for the bacteria to come through the shell to the inside.
Mm-hmm. So then Alicio has a question. He's asking, what is the effect of formaldehyde use on embryonic mortality during incubation?
Most of the formaldehyde use that we see at this point is done in the hatchers.
Yeah.
So you're talking about, okay, what does it do in the early incubation? It's really not affecting our whole incubation. It's affecting the very tail end of our hatch. And what we're trying to do is, is killing pathogens there to get a chick with less pathogenic challenges when they hatch. So if you're seeing some mortality and it's anywhere in the incubation period, formaldehyde don't have anything to do with that, but it can be misused. I personally would like to see a point in time where we are not using formaldehyde in the hatcheries. I think often it is done out of necessity. Some of our hatcheries are older hatcheries, difficult to clean every nook and cranny in those hatcheries because they are older. And sometimes that is a necessary thing to do, use formaldehyde in the hatcheries, and there are benefits to it as far as chick livability at placement. However, I would personally like to see a point where we're managing our hatcheries in a manner that we don't have to do that. It's just not going to be possible all the time in some of our older facilities.
Yeah, I definitely agree with that. It seems a lot of time that it's essentially the Band-Aid that fixes problems further up in the chain. So if you can eliminate those, then you can eventually eliminate the use of formaldehyde, which ultimately is ideal for your workers as well. And I know that in North America in particular, we're facing increased pressure to eliminate formaldehyde in all of our hatcheries from the different governmental agencies that are around here. So, any more questions? Oh, we do. Jacob says he's sorry for blowing up with questions. No, thank you. Actually, we really enjoy your questions.
Keep them coming, Jacob.
Keep them coming. We're here all day. So Jacob works specifically in vaccine and specific pathogen-free eggs. He wants to know, will a 2-hour loss of incubator air circulation at day 18, coupled with a temperature drop of 3 to 5 degrees Fahrenheit, drastically affect the pipped dead in shell? What should he look for in his breakouts to troubleshoot that issue?
If you had a 18 days, if your air movement, I guess your air movements was seized for a couple of hours, the temperature drop was not a horrible thing to have happen if your air is not getting air movement. Typically what you're going to see at 18 days, if you don't get adequate air movement, you're typically going to see heat just rise to unmanageable conditions. So, I mean, you're kind of fortunate you had both of them occur there at the same time. However, day 18, if that happened at 18, we talked about at 18, 19 is when that internal pipping start to occur, and we do see some internal pipping at 18. Again, that's one of the points in time when the chicks are starting to pip and their respiratory system's trying to work. Well, you can imagine if you've got no air movement in there, you're building up CO2 rapidly, you're typically building up heat, probably building up some humidity too in your machines, especially if they're tight. You're going to see some 19, 20 day, and even 21 day, but you're going to definitely see some increased latent, probably in that PIP stage there. Surprised that you would have lack of air movement for a couple of hours and a temperature drop. If you've got a full incubator with a lot of embryos developing, producing heat, then typically it's not, those two aren't going to go together. But
as I'm kind of wondering if maybe that's a function of where the temperature sensor is in the cabinet that he was using. Maybe it just wasn't picking up the fact that the actual, racks full of eggs, the actual egg mass was increasing in temperature, and if the air was dropping.
Yeah, and if you had your air circulation stopped, if you've got a temperature probe that's in a point in the machine that is a spot, I mean, it's not sensing the whole machine itself because you don't have air movement. Yeah, you could have had a pocket in there where it was not. But
so he's added the cause of the temperature drop. They opened the doors to replace the motor on the fan.
Okay, well
that makes sense.
No, that's actually going to, anytime you have something like that, it's going to delay some development. If temperature drop's going to delay development, the lack of air movement in there is going to cause problems as far as potential suffocation, not get enough oxygen when chicks are starting to pip and get ready to hatch. So yes, the lack of air movement is going to cause you some late mortality. The drop in temperature, I don't think is as big of an issue because at that point the embryos are exothermic, they're producing more heat than they need anyway. So you might have a temperature drop in the air, but I would suspect if you actually took temperature of the chicks and embryos themselves, you probably did not see much of a temperature drop at all because they're producing more heat than they need.
Yeah.
So that actually probably was a good thing that that door was open
Yeah.
when there was no fan air movement. Otherwise, the temperature would have gone the other direction.
Yeah, and that would be our recommendation, if you lost cooling in your cabinets, your chiller went down, something like that, loss of air movement, in that late stages of incubation, that you do open the doors, sometimes even pull the racks right out. And what you can actually do would also be to increase the temperature on your incubator room a little bit if you need to, just kind of balance that out. But generally, if you have, a loss of cooling, or in this case, a loss of air movement, pull them out so that they're not crammed in so tight, building up heat.
Early in incubation, leave the door shut. If your fans go out, leave the door shut early in incubation so you don't lose heat. Late in incubation, open the doors and pull them out so you don't build too much heat.
Yeah. Now, is there anything after having this this loss of circulation, temperature drop, should they be looking at maybe giving a couple more hours in the hatcher, or?
I definitely would give a little bit more time. Anytime you have something, particularly with the temperature drop, that might stall normal development, I would give them a little bit more time to hatch out. The thing I would still be concerned with is that period of time where you didn't have air movement, that your temperature, like I said, may have dropped where it was registering, but I suspect you probably had some pockets in that machine that were really hot because there was no air being pulled through the racks of eggs. So you may have had some in there where you did get hot. So I would actually give it a little bit of time, just because you don't really know for sure what happened. But at the same time, you don't want to pull them early for certain. You may just kind of wait a little bit longer to see if you can pull up any stragglers, but it will definitely affect your hatch.
For sure.
I would suspect if you were to look at the racks in there where you start seeing more loss, it might be those eggs that are right in the middle.
Yeah.
Because if you didn't have air movement through there, you're going to have pockets in there that got really hot with no air being pulled over them.
Yeah. And you can always use those little infrared handheld thermometers just to give you a ballpark idea on where your temperatures are setting. And of course, your eggs in the middle of the pack, in the middle racks, are going to be the ones that are going to get the hottest, because they have the most other eggs around them putting off heat. And that way you can at least keep an eye on where everybody is, and whether you need to do more to help them cool, or whether you feel that they're getting too cold at that point. So, all right. If you have any more questions, drop them in real quick. Like I said, as usual, this will be up on YouTube. You'll receive a link in the post-attendee email to be able to view it. We're also going to put the PDFs up on the website, jamesway.com/webinar-Wednesdays. As far as what we have coming up next month, we actually have 2 webinars for you. And the first one is going to be on March 7th, and Curtis will be joining me. You may remember him from the 5 Things You May Not Know About HatchCom webinar. We're going to be doing basically a follow-up to that. HatchCom 4 is ready to go. So we're going to be walking you guys through HatchCom 4, how to use it, what's new, what's different, what new capabilities we added for you. So that'll be a really good educational session, really. Bring all your questions about the system, because we'll be here. We'll be able to answer them all for you. Then March 21st, Dr. Bramwell is going to be back again, along with Jerry Garrison, and we are going to be doing the metabolic heat webinar that unfortunately we missed back in the fall for you all. So we'll be covering that topic on March 21st. As usual, all those links to register are on the website at jamesway.com/webinar-Wednesdays. And of course, from there is also links to the YouTube videos, and we will throw those PDFs up there for you as well. As there are no more questions, I want to thank you all for attending. It was great to see everyone and have a lot of good questions, a lot of good information and discussion there. Thank you so much, and we hope to see you in March.